Hey everyone, and welcome. Ever wonder what really happens behind the scenes in global logistics? Well, today we're pulling back the curtain on the digital pulse, the 30 essential SAP commands that are basically running the show. Let's get right into it.
So think about it. You click buy on your phone, and just a day or two later, a package shows up. It seems like magic, right? But what's really going on? That single click kicks off this insane chain reaction. We're talking warehouses, trucks, financial systems, all moving in sync. So how? How does the system even know where to start?
Well, it's not magic, it's more like a digital symphony. And every symphony needs a conductor with a score, right? In this case, the score is a handful of really powerful commands, or what we call transaction codes. We've boiled it down to the 30 absolute key players, the ones that orchestrate literally everything, from planning the perfect route to making sure the driver gets paid. Okay, so here's how we're going to break it down. First, we'll look at the big picture. Then, we'll actually follow an order's journey from the moment you click to when it lands on your doorstep. After that, we'll dive into the brain of the operation, see what keeps the system healthy, and finish up with the data that holds it all together. So let's just set the stage here. The scale we're talking about is mind-blowing. Millions and millions of products moving around the globe every single day. And a massive chunk of that whole global ballet is choreographed by SAP's systems, specifically transportation management and extended warehouse management. And these 30 codes we're talking about, they are the literal language of that ballet. It's how everything communicates. All right, to really get a grip on this, let's make it personal. We're going to follow the life of one single shipment. We'll trace its journey, but not just on a map. We're going to follow its digital footprint, command by command, to see how it actually happens. So this is the basic life story of our package. It all begins when an order is placed. That creates a delivery. Then you've got the physical stuff happening, picking, packing in the warehouse. Next, it's confirmed as delivered, and finally, someone gets the bill. Pretty straightforward, right? Now let's look at the specific codes that make each of these steps happen.
Everything, and I mean everything, starts right here with VA01. This is the big bang, the starting pistol for the whole race. When that sales order gets created, the system generates something called a freight unit. The best way to think about it is like the shipment's digital birth certificate. Suddenly, this thing exists in the system and it's screaming, hey, I need a plan. Absolutely nothing can move until this happens.
Okay, this is where the digital world meets the real world, the warehouse floor. VL01N is the command that basically tells the planning system, hey, get ready, a delivery is coming. Then VL02N is the action hub. It's what the folks in the warehouse use to guide the actual picking, packing, and getting the goods out the door. And finally, you have VLPOD. Think of it as the digital handshake at the end, confirming, yep, the package made it. And of course, logistics isn't free. Someone's got to pay the carrier who did all the work, right? That's where Miro comes in. This is the absolutely critical final step. It's the bridge between the logistics team and the finance department. It makes sure the shipping company gets paid, and paid correctly. This closes the financial loop on the entire journey. So, while all that physical stuff was happening, picking, packing, shipping, something really cool was going on in the background. A powerful digital brain was churning through thousands, maybe millions of calculations to figure out the absolute best, most efficient way to get that package to its destination. Let's peel back the cover and see how that brain actually works. You see, this planning engine isn't just one monolithic thing. It's more like a team of 3 highly specialized experts, and this is super important. Each one answers a very different question. First, you've got the VSR engine. Its job is to ask, what's the best route? Then you have the carrier selection engine, which asks, okay, who is the best and cheapest carrier for this job? And finally, my personal favorite, the load optimization engine, which is basically playing a high-stakes game of 3D Tetris, asking, how do we fit all this stuff into the truck? By breaking the problem down like this, the system can solve mind-bogglingly complex puzzles in seconds. But what happens when that super smart brain makes a decision that just doesn't make sense to you? A lot of planners feel like the optimizer is just this black box. You put data in, a plan comes out, and you have no idea why. This quote just nails it. What you need is a flight recorder, something that tells you exactly what happened inside that box. And that flight recorder has a name, RCC_log. For anyone troubleshooting the system, this tool is your absolute best friend. It lets you crack open that black box and see the exact inputs and outputs. It shows you why the system chose that weird route or that specific carrier. It's all about bringing transparency and control back to a process that can feel totally automated.
Okay, so we've seen the day-to-day action and we've looked inside the planning brain. But what's holding all of this up? What's the technical backbone that the whole thing is built on? That's what we're diving into next. The codes that are used to build, configure, and maintain the entire system.
Listen, if you only remember one code from this entire section, make it this one, SPR. Think of it as the master control panel, the settings menu for the entire supply chain system. This isn't something you use for daily tasks. No, this is where the architects, the consultants and admins go to define the fundamental rules of the game. We're talking shipping lanes, costs, warehouse layouts, literally everything. This is such a perfect example of a key concept in these systems, the partnership between automation and monitoring. So on one side, you have a program that's just running quietly in the background, automatically creating financial documents. It's the engine. But how do you know if that engine is working? That's where the other side comes in. SLG1 is the application log. It's your dashboard. It's where you look to see if everything ran smoothly or if something broke. The engine and the dashboard, they go hand in hand. So you have all these different systems, right? How do they actually talk to each other? Well, it's basically like an old school phone system. SM59 is the phone book. It has all the addresses or RFC destinations. BD54 is the caller ID, what we call the logical system. So the system on the other end knows who's calling. BD64 is like the script, the rules of the conversation. That's your distribution model. And then you have SMQS, who's the busy switchboard operator, managing the queue and making sure all the calls get connected in the right order. All right, we're heading into our final section. Let's bring it all home by looking at the most fundamental layer of all, the data itself. Everything we've just talked about, every single process, is built on a foundation of what we call master data. And more, it's all being executed using modern cloud functions. Now, this is a really, really important distinction to understand. On one side, you have your master data. These are the static, foundational rules of your network. Think of it like writing the Constitution. Codes like 3TL and 4DE are used to define who your carriers are and how much you'll pay them. That's the rulebook. On the other side, you have the active transactional functions. These are the tools in your daily toolkit, like 6W2 and 6W4, that you use to actually plan a shipment or settle an invoice based on the rules you already wrote. So you have the rulebook and you have the toolkit you use every day. And there it is, 30. 30 essential commands, programs, and functions. Together, they form the digital DNA of a modern supply chain. From that very first sales order all the way to a super complex optimization run, this is the language that makes global commerce actually work. So that leaves us with one final pretty big question to think about. We've just walked through this incredible system that's a mix of powerful automated engines and crucial human commands. As automation and AI keep getting smarter, which one of these human-driven commands do you think will be the first to just disappear? What happens to the supply chain when the system doesn't need a human to press the button anymore?